Researchers got production AI coding assistants, Cursor, Windsurf, Copilot, Cline, to clone a fake GitHub repo and run malware, just by asking for a project by name. Ask an AI coding assistant to clone a project, and it has to guess the exact GitHub owner and repo name. Large language models guess wrong constantly, and they guess wrong the same way every time. Researchers at Tel Aviv University, Technion, and Intuit found the highest probability wrong guess for popular projects, registered that exact fake repo, and loaded it with a payload. Here's the chain. Step 1. The model hallucinates a plausible-looking repo name, like LibrePods/LibrePods, when a developer asks for a project called LibrePods. Step 2. Attackers already registered that exact name on GitHub with malicious code inside. Step 3. The assistant fetches it, and because it's agentic with shell access, runs whatever instructions are in it. Step 4. That same hallucination repeats across different users and different models. So one squatted repo compromises many machines without ever targeting a specific person. The paper's own name for the endgame is an agentic botnet, one hallucination, many independent machines, no targeting required. This is the real example from the paper. A developer asks their assistant, quote, "Clone LibrePods for me," unquote. The model doesn't know the real GitHub org, so it guesses. Across multiple tested models, the guess was the same, LibrePods/LibrePods. That repo didn't exist yet, so the researchers registered it themselves with a placeholder payload and confirmed the assistants fetched and ran it without asking first. Here's what running it actually looks like. The assistant clones the squatted repo without confirming the org matches anything real, then treats install.sh as trustworthy because it's already sitting on disk, and runs it. In the researchers' tests, the payload was a harmless placeholder that just proved it executed. Nothing here trips a malware signature because it's freshly written for this one repo. The team tested Cursor, Windsurf, Copilot Chat, and Cline for full code execution separately from OpenClaw, ZeroClaw, and NanoClaw, the open source personal assistant family sharing a plugin marketplace called Claw Hub. Windsurf hit 65%, 13 out of 20 trials. Cline hit 45%. Copilot Chat hit 35% across 7 attempted trials. Plain Cursor landed around 20 to 25%. But Cursor CLI, which runs a search step before fetching, scored lower than the IDE version on the same tests. The OpenClaw family hit a 100%, 10 out of 10 every single time. Age is the biggest predictor here. Repos from before 2019 hallucinated in only about 9% of tests because models have seen the real name thousands of times in training data. Recent repos, the ones models have barely seen, hallucinated at a 92.4% mean rate. Skill installations on the AI agent marketplaces topped out at 100%. But context changes everything. When a tested setup let the model fetch blind, hallucination hit 99%. Add one step, search before you fetch, and that same setup dropped to 6.6%. The fix isn't a new model, it's one extra step. The skill marketplace side of this has 2 named failure patterns. V1 is word removal. The model drops a qualifying word like skill from the request. So skill vetter resolves down to the bare, squattable name vetter in 95% of tested attempts. V2 is display name divergence. When a skill's human readable name doesn't match its actual machine slug, the model guesses wrong 85 to 100% of the time. Baidu Wenku AI PPT hallucinated to Baidu Wenku IPPT at 100%. DuckDuckGo web search hallucinated to an unregistered slug, DuckDuckGo web search. 2 things separated the tools that got compromised less from the ones that didn't. The search step you just saw is the biggest lever. Grounding the agent in a real lookup before it clones or installs is what collapsed that hallucination rate. Permission gating matters too. Cursor CLI's built-in search cut its risk versus the plain IDE, while Gemini CLI's lack of any verification step was called out as amplifying its exposure. Auto-run modes remove the one human checkpoint that would catch this. Claude Code's skip permissions flag and Gemini CLI's YOLO mode both let the agent act without anyone looking first. None of this is exotic security engineering. It's mostly just turning a default back on. The researchers were blunt about the ceiling on their own numbers. They call their published results, quote, only a lower bound on what attackers could do, unquote, since they used harmless placeholder payloads and didn't optimize for stealth. A criminal not worried about getting caught could do worse than what got demonstrated here. This isn't the first time AI hallucination became an attack surface. In April 2025, Seth Larson at the Python Software Foundation coined slop squatting for fake NPM and PyPI packages. By the way, I post one of these daily. Subscribe if this is your thing. A Ucenic study that year found 19.7% of packages in AI-generated code didn't exist, and 43% of those fake names recurred across reruns. HalluSquatting escalates that on July 8, 2026, aiming the same trick at GitHub repos and AI agent skill marketplaces, with researchers actively probing for the highest probability wrong guess instead of waiting for one to happen. If you use an AI coding assistant with shell access, there are concrete things to change today. First, turn off auto run. Claude Code's skip permissions mode and Gemini CLI's YOLO mode both let the agent execute whatever it fetches without you seeing it first. Turn them off and confirm every clone and install by hand. Second, if your tool has a search or verify step before fetching, like Cursor CLI's, leave it on. It's the single biggest lever the researchers found. Third, treat clone, install, and fetch as trust boundaries in your own head, not routine steps, the same way you double-check before running a script you downloaded from a random link. Fourth, this carries over from the older slop squatting problem too. Commit your lock files, package lock, don't, JSON, poetry, .lock, whatever your stack uses, with integrity hashes, so a hallucinated dependency can't silently slip into a build even if the AI suggests it once. Fifth, for anything that touches CI or production, resolve installs against an internal package mirror you control, not the public registry directly, and never let an agent auto-install a dependency you've never seen without a human checking its age and maintainer history first. Here's the opinion part. This is real, demonstrated research against production tools, not a hypothetical. The team actually registered a live GitHub repo, got real assistants to fetch it, and confirmed execution. But it's also not a live crime wave. No source reports an actual victim compromised by a criminal using this technique. The payloads tested were harmless placeholders, and the researchers deliberately withheld the exact probing method, so it's harder to copy before vendors patch. What that means for you: don't panic, but don't treat agentic coding tools like a search engine either. The entire value of these assistants is that they take action for you. Clone this, install that, run this script. That same convenience is the attack surface. Autorun isn't reckless everywhere. Inside a disposable container or a CI sandbox with no real credentials attached, let it run unsupervised. That's what sandboxes are for. The actual risk is running agentic tools this loose on your daily laptop with your SSH keys and cloud credentials sitting right there. Every agentic tool ships with a trade-off between how much you let it do unsupervised and how much you're trusting a model's guess about what a name resolves to. Right now, most default configurations trust that guess more than the paper says they should. HalluSquatting won't be the last time an AI agent's confidence gets weaponized against it. If you're running Cursor, Copilot, Cline, or anything with shell access, go check whether autorun is on right now. I cover stuff like this, agentic tool security, local model setups, every week. Subscribe, and I'll see you in the next one.